everybody to Cloud RI Hack Night, or really Cloud RI Meetup, we used to call Hack Night. Thanks for coming and joining. Just to give a little intro, my name is Scott Milano. I'm one of the directors of engineering here at Kensington. I see some new faces, I believe, which is good. Today we have Greg here, who's going to do a talk on some cool serverless stuff and data pipelines. I won't get too much into it, but we typically do these meetups once a month. Obviously, the holiday season, we're probably not going to do December and start back up in January, but we ask out to the community for ideas of topics people are interested in. We've had people come and present topics as well. We do that as well. We look for any feedback. We're also, on top of this, Kensington as a company. We are professional services company that works with various enterprises building microservices and digital transformations for these companies. We have offices in Providence, Denver, New York, LA, and Guadalajara, Mexico. So we are, if you look at the website, we are hiring in various roles in various different offices. So please take a look at that. But we hope you enjoy the meetup and discussion. And again, any feedback is appreciated. And give it up to Greg. Cats and
There it is, one that works. How's it going, everyone? I'm Greg Lavelle. I'm going to talk to you today about scalable data ingestion with serverless data pipelines. So, good timing. Oh my God. Well, I had the timer on. I had the timer on at the same time. I was trying to switch. I guess I didn't like that. This is what we're going to talk about. So the goals of a basic data pipeline. We're going to talk about benefits of taking that pipeline serverless. Then talk about specific serverless technologies to use. Going to be focused around AWS this talk because that's what I know. We're going to take a look at our architecture. So we built a serverless data pipeline in order to collect data that we would later use for machine learning. We are going to do a quick demo. It's going to be just a basic, very basic data pipeline using the three components that I outline in serverless technologies. And then we'll talk about lessons learned, so what I learned from building our data pipeline. All right. So the three main goals of a data pipeline are data capture, transfer and processing, and storage. So data is most useful in bulk. So you need a system that's able to accept large quantities of data at the same time. It needs to be scalable, needs to be reliable, because you want to make sure you get all the data. Transfer and processing. So once the data is in our system, we need to be able to transfer it efficiently and in a way that makes it easy to use down the line. We want to make sure it's delivered to its destination efficiently, and we want to provide opportunities for that data to be further processed and manipulated along the way. So we get the storage. So our storage solution needs to be as scalable as possible because it's going to be accepting a lot of data. It needs to be reliable, and we need to be able to access our data when we're ready to use it. So here we go into what makes serverless cool. So fair warning, you're going to see the word scalable a lot tonight because it's one of the main benefits of serverless for these data pipelines. The other main benefit is that the services are managed. So AWS, you give a little bit of code and your custom code, and Lambda takes care of all the scaling on its own. Same thing with Kinesis Firehose, which we'll also talk about, also S3. They're all managed, they're all scalable right out of the box. So for data capture, we'll talk about Lambda. Scales from 0 to 100, from nothing, no traffic at all the way up to gigs of data coming in at once. Transform processing, same deal with Firehose, Kinesis. And with Kinesis, you're provided with multiple opportunities along the way to access that data in flight. So for storage, serverless storage is fast and scalable, right out of the box, as I mentioned before. Like I mentioned, we're going to be using Amazon flavored serverless. Data capture, we're using Lambda, and Lambdas are triggered by events. So those work in concert for data capture. Transform processing opportunities, we're going to be using Kinesis Firehose. Any further processing off of that transfer is also going to be done with AWS Lambda. Any processing is done with Lambda. And then for storage, we're going to be using S3 because it works seamlessly with Firehose and because it's simple, it's quick, and it works. So, I'm going to first talk about Lambda. So, serverless functions are just bite-sized bits of code that run in response to events. So, something happens, your code runs in response to that. When the lambdas are triggered, your code runs, it's spun up, sorry, the code does its work, and then after about 45 minutes, we'll average 45 minutes, that instance is torn down, saving space and processing, you're not paying for what you're not using. They scale horizontally, so when requests come in, multiple instances of your running code can be used, spun up, and utilized that way. Pricing is about 20 cents per million requests. There's a free tier, which gives you the first million requests per month free. And for the compute power, that's a very, very small fraction of what's out there. So these are some of the event triggers we're using to trigger our lambdas. We've got API Gateway, which lets you make HTTP requests to trigger lambdas. We use S3 events. So when data is written to one of your buckets in S3, you can have a lambda trigger off of that. We've been using that for post-processing. So we collect the data, it goes to like a raw data bucket through Firehose. And then when that raw data comes in, we trigger another lambda as a post-processor to further process the data, make it more useful for our specific purposes. We've got CloudWatch for timed events. You want to use them kind of strategically because they're not, you would use them toward the front of your data pipeline as a way of kicking off the process. If you use them toward the end, it leads to kind of a scalability issue. You can run into deficits in your losses, kind of walls in your processing power because you're trying to process a lot of data at once. We've got Kinesis Firehose, so we're using it to buffer incoming data. When you're receiving data through whatever entry point you've set up, you don't want to immediately write that data to an S3 bucket because you're going to end up with a bunch of small, almost individually useless little bits of data that's going to be super expensive to not only write, but to read. So you're going to have to go through and individually read each one. So Kinesis Firehose takes all that data. You set a buffer limit, a max time, and a max amount of data, and whichever one it hits first collects that data in that chunk and then writes it. So that minimizes the amount of reading and writing you have to do. It gives you the option to manipulate data in flight. So as it comes in, you can almost have like a side attached lambda that you pass your data out to and bring it back in a different form before you save it. We didn't really go for that setup with our pipeline, but it's an option. It's valid. Quick and easy writes to S3. You basically pass the data to Firehose, and Firehose takes care of the writes all by itself. And then pricing for that is about 3.5 cents per gig of data ingested, so it's super cheap as well. Especially for our purposes, we weren't getting too much. Okay, so now we're at S3. So it's auto-scaling, like I mentioned before. It's managed object storage that works seamlessly with Firehose, as I mentioned in the last slide. So objects are stored in buckets, bucket head down there, and they're partitioned by prefix, which is also kind of named for a subfolder. Okay. So now I'm going to talk through our pipelines architecture, kind of broken out into 5 different parts. We've got data capture first, which is basically what I mentioned before. You get raw data in, and if you want to enrich it with additional metadata, that'd be the point where you do that. Then we get to raw storage. So any enriched data, it's unformatted, it's passed to Kinesis Firehose, and then it's saved raw. We did that so that if there were changes in requirements on the back end, we could always process the raw data and come out with a different outcome. So we got a post-processor. So at this point, the data is raw. Post-processor is a way of manipulating the data so that we can transfer it to a more usable format for our purposes. And in our case, there were a couple of different data sources. So in the post-processor for us, we kind of make them conform to a shared schema. And then we get to process storage. So that's kind of self-explanatory. And then we get to data use and extraction, where the data is actually used. So I've got another graphic that goes through the first 4 stages, and we leave kind of data use and extraction to kind of separate, because it's not really part of the pipeline. And here is our pipelines architecture. So as I mentioned before, this was built in order to collect machine learning data. Specifically, we wanted to use the data in a word to vector algorithm. So it was meant to collect a ton of word data, which we later look at for context on individual words. Kind of just like a foray into the world of machine learning for us. So what we've got here is kind of the heart of the pipeline. You'll see that everything pretty much relies on web scraper here. So that's its own individual lambda. What's feeding that lambda, that web scraper, is Slack, RSS, and Twitter stream. So when each one of these is actually its own separate little data capture system. But for simplicity, I kind of condensed it. So each of these would have its own entry point, its own starter lambda, and its own Firehose. So from Slack, RSS, and Twitter, we are collecting, in the case of Slack and Twitter, individual messages. And if there is a link in one of those messages, we persist the whole message, and we pass the link that we find into the web scraper. For RSS feeds, we maintain a list of RSS feeds that we want to follow, and on a nightly basis with those CloudWatch events that I mentioned earlier, we pull in the past day's worth of articles from those RSS feeds and pass all of those into the web scraper. So that web scraper also works recursively, up to I think a depth of 2. So any links that we find on that page, we run those through another instance of the web scraper. And if any links we find on those pages, we run through another instance of the web scraper. So each link we get kind of flows into a ton of traffic of the pipeline. It's actually really cool to watch and like the logs and see everything just light up. But then we get to raw storage. So the web scraper passes any HTML finds into the raw data fire hose, which writes to the raw data bucket. So within the raw data bucket, there's a prefix specifically for web scrape data, and then there's also a prefix for Slack data and Twitter data. So RSS is basically just the links anyway, so we didn't think we need to persist lists of those articles per night. But that's all in the raw data bucket. So we collect everything, so if we ever want to go back and change the way we process the data, we have that option. So from the raw data bucket, this line here is triggered via HTML post processor. So every time there's a write to the raw bucket under the web scrape prefix, that line triggers. And it basically just takes, I believe it's p tags. Yeah. It's any text that you find within the p tags. It pulls that text out, saves it as a big chunk of text, and passes it to the process data fire hose. Process data fire hose passes its data to process bucket. And then each of these sources, Slack and Twitter, have their own post-processor lambdas that also trigger off of writes to the raw bucket under these different prefixes, and all that word data ends up in the same place at the very end, the process bucket. So here we go. So I just got a quick little demo set up. We're going to take a dummy data generator lambda. We're going to create a fire hose to work with it and a bucket to write to. The lambda is just going to simulate data generation. I have kind of like an Ipsum generator set up so that it's creating a set number of paragraphs of text, and on each invocation through API gateway of that lambda, it'll just pop into Firehose another couple of paragraphs with a user and a ingestion date time. So you're going to see a bunch of little individual objects at the very end. So yeah, of course. Sorry, I should have paused for questions.
I have a question for the previous slide, the architecture.
Sure.
And you mentioned for Firehose, there's an option to do transformations in flight.
Yep.
Is that for processor lambda that option, or is it not scaled, or did you have to use lambda to process the data?
We could have done it that way. We could have done it. Would basically be the same thing. It would just be a almost a less explicit like chain is what my thinking was. Because in that case you would have a kind of a lambda here that triggers off of this fire hose, and then that lambda would have would pass through a process data fire hose in the bucket. I figured this way was a little more linear, a little easier to follow, and a little easier to reason about. So that's why I did it that way.
Any good examples for the raw data in the area bucket?
What's that? I'm sorry?
That way, that architecture gives you a chance to store that raw data into like an intermediary.
It does.
Bucket.
Yep. Yep. So Firehose also gives you that ability. It's a little checkbox if you decide to transform the data in flight. I'll show you that option when we get to the Firehose.
Yeah, one of the big factors of the raw data was, if you go through all this effort, a lot of the data was from real time from Slack and Twitter. And then, like you said, we determined tomorrow, like we want to process it differently. We realize the algorithm is better to take this data, split it up this way. We want to touch any of the raw data, but we want to persist it, so we have to go back and check it and Slack and back. So for that part, I was more sort of drop it in, put it in, and then you can always rewrite the processor, but we have to log in. Obviously, machine learning, the amount of data is hugely important, so we can keep growing and growing and growing and then reprocess the data.
All right. So first step is going to be to create our S3 bucket. Giant cursor, small text, real bad. Let me see if I can fix that. Is that a little bit better? All right, so let me find my naming. So we're going to give the bucket a name. I chose demo data bucket. Nice and simple. Everything I've got is in Ohio, East Ohio. This is my personal account. We aren't going to copy our settings from an existing bucket, so we'll hit next. Bucket name already exists. Did it not delete my old one? And bucket 2. Oh boy. All right. Keep all versions in the same bucket. We can go for the defaults here. The only thing I do want to do is hit default encryption. KMS. So again, this is access control. I'm going to keep the defaults. Hit next. Everything looks good. Create the bucket. Demo data bucket 2. Yeah. It should be, I mean, I deleted a demo data bucket 1, demo data bucket earlier. I would have thought it would have been removed from the system at that point, but possibly when I delete this one, someone's going to go for 2. So let's go to create our Kinesis Firehose. Right. Getting started with Amazon Kinesis. So Firehose is going to be this little box here on the right, top right. We're going to hit create delivery stream. And we're going to give our delivery stream a name. Please, please tell me that this is going to work just fine.
I think every bucket is global for the entire user base, whereas Kinesis is
Hopefully. All right, so demo Firehose. Hopefully we don't need demo Firehose too. We're going to choose direct put instead of Kinesis stream here. Direct put just allows us to invoke the Firehose from our lambdas. So we're just passing data from our lambdas into our Firehoses. Next. So these are the options to transform in flight. Right here, so record transformation. So what it's going to do is every time it gets a piece of data, it's going to pass that data to whatever lambda you set up to process it. And then you're going to have to add it to an object that Firehose recognizes as processed data and pass it back to Firehose, which is then persisted. If you choose that option, you also get the option to save a copy of the raw data that comes in as well. Convert record format. Nope, not going to worry about that. Next. All right. So selecting destination, we're going to send our data S3. You have the option for Redshift, Elasticsearch, or Splunk. Let's see, source bucket. So we're going to send this data to demo data bucket 2, and we're going to send it to demo data bucket 2 under the prefix random text.
That's a maybe Splunk.
Yeah, maybe that's
Reinvestor.
Yeah, I'm wondering if anything actually we're seeing for the first time right now.
Yeah, so rough. So right now, what Firehose does is it creates kind of a subdirectory structure where it separates by date. So each portion of the date is broken out into its own separate prefix past this point. If we don't add a backtick there, the first folder you end up with is going to be named random text and then probably 0, what, or 1, 0, 2, 0, 2, 1, sorry, 11 for the month. So we just make sure we have that slash in there. Next. Okay, so now we get to the buffer size. So the defaults are 5 megs and 300 seconds. We're going to reduce that to 60 seconds, so I only have to talk for 60 seconds while it goes through.
6 seconds.
Let's see. You have options for compression, which we aren't going to worry about. S3 encryption, we already set up encryption on the S3 bucket side, so we don't have to worry about that. Error logging is automatically enabled, so we can leave that as it is. We are going to need an IAM role for this Firehose so that it has access to our S3 bucket. Let's see, demo Firehose delivery role. I had these set up earlier. I hope so. Demo S3 full right. That sounds like the one to me. We're going to hit next. And that should be all set. Yeah. So that should be all set now. And we'll hit create delivery stream. Creating. Hopefully that's not going to give us an error. So while that's going, like 3 or 4 minutes. I haven't actually watched it spin.
Wait now,
No, it should be much quicker than that. So now we will talk about the Lambda itself, named Demo Data Generator. It's triggered, you can see the trigger on the left side, triggered by API Gateway. This trigger was configured by API Gateway when I set it up. Super easy, just say you want to pass any request through to a Lambda, and this will pop up. You can set other triggers on the left side here. So we've got the CloudWatch fence there, IoT stuff, sounds pretty cool. You can set them to trigger on writes to S3. This is the Kinesis side-loaded in-flight processing option, and then SMS. So it has API Gateway has permission to access our Lambda, and our Lambda has permission to write to Kinesis Firehose and CloudWatch, which is default for Lambdas. I've already uploaded the code, which I'm going to show you in a minute. It's the handler class that runs when Lambda runs, is under the handler package within the project, under dummy data generator, and the name of the function that's going to be triggered when this Lambda is called is handler request. So I'll show you that in a minute as well. Scroll down, you can add tags here just so it's easy to search and sort and locate stuff. Environment variables. execution role. So I've already set this up. Basically, it has permission to write to Firehose and permission to write to CloudWatch logs. Well, yeah. The other important part here, under basic settings, you can add a description. You can increase or decrease the amount of memory that you give to your lambdas. So you allocate memory. It costs a little bit more for more memory, obviously. And then timeout. So this lambda will run for 15 seconds, and then it will time out. If your code takes more than 15 seconds to run, it's going to time out. You're going to lose the data you take in. I would like to bump this up to at least 30 seconds. But your lambda execution may take longer. If you're seeing a lot of timeout errors, that's probably the first culprit. If you're seeing out of memory errors, bump up the memory. If you find yourself manipulating either of these too much, you might want to rethink how you're working with your code, because it might you might kind of run into a scaling issue if you find yourself messing with this too much. And that should be it for us now. So I'm going to hit save, just so that 30 seconds is saved. And we can go back to Firehose, make sure that's working. Yeah, sure.
Can you click on the test button up to the right?
Yep.
Why don't you click test?
If I click test right now, I don't believe it'll pass that to Firehose, or it should, if I configure this test event. So let's see. Haven't done this.
Okay, we're going to have to do it on the fly.
It should work.
It allows you to call, basically test your random function and pass in like a sample JSON to your random function to test it and execute.
Make sure you
To make sure like the code's up, listening, and running.
Yeah, without having to set up the triggers.
Cases, because we are doing it one and we are
All right, so our Firehose is all set. Our lambda's saved. Let me show you the code for that lambda super quick. Switch this over. Okay. So, dark mode. All right. Super hard to manipulate this gigantic cursor. All right. So you can see we've got these. We've got the handler package. Just got one class. This entire thing is one class. Dummy data generator there. We've got the handler request function here. That's what's going to trigger when we set off our lambda to run. I've got everything else pulled out of the initial lambda because subsequent this whole section here is rebuilt every time you run the lambda. But anything outside the handler request or whatever function you give it is kind of saved memory, so it doesn't have to be rebuilt every single time you run it. So any logic, any more intensive stuff is outside of the original handle request function. So we initialize our logger here. We do work, which is the body of the lambda here. We generate our random text paragraphs. I'm using what is it? Ipsum? No, Lorem. The Lorem library. So we'll pop down to generate data. Creating a map. We're putting the posted by. So Lorem has an option to generate a random name. I use that. We add our random text. So get paragraphs between 1 and 7. It's just a random number of paragraphs. And ingestion date time. We pass that back. Let's do work. And we create our record. So the record is what we're going to pass to Firehose. So we set the data on the record. We highlight this. So data here is that JSON node that we generated, converting it to a string, and we're wrapping it in a byte buffer because that's what Firehose wants to consume. We're placing it within our record, and then we're passing this record to Firehose. So put record request with delivery stream name. I set the delivery stream name up here, demo Firehose, which is why I was really hoping that it would generate that Firehose for me, so I didn't have to go back and change anything. We get the result of that that put request, which is going to be an ID from Firehose. And then we pass that to the logger. And then we're also returning it up here. So what I did was I packaged this as a jar and popped it onto that Lambda page here under upload. So upload zip for jar, upload, pop your jar on, and make sure your runtime is set to, well, whatever you're using. In this case, Java. But that should be it. That should run. So to test that theory, I've got the link to the API gateway endpoint that's going to trigger the Lambda to run. I'm just going to pop that here. And so what we should see back from this is just that ID from Firehose telling us that the put request is successful. What you're going to see here first is cold start time, because I haven't run this in a while. It's going to take a second or two to spin up that first Lambda instance. And go. 1, 2, 3, 4, 5, 6. It's a slow one, but there we go. Record ID. So we know that it was passed successfully to Firehose. From there, any subsequent calls, because the Lambda's already been warmed up, you don't have that cold start time to worry about. F5, we'll refresh. The ID's changing, but it's instant. Or near instant. Yep. So I'm just gonna pass a bit of data here. Keep clicking. I could have scripted this. This is more fun. Click, 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 click. All right, so that should be good enough. So now we're going to navigate back over to our S3 bucket. Pop this open. Go to the demo data bucket. And you'll see we've got the random text folder here, the subdirectory that we set up. And we've already started receiving our first sets of data. So 2018, the year, if we hadn't put that slash mark after the prefix we chose, that random text there, we would have had random text 2018. A little stupid, but okay, I guess.
Instead of getting random text, you just call it random text.
So this is the folder structure that Firehose is implementing automatically. You've got the year, you've got the, I can't tell if that's the month, month. You've got the day, and then you've got time. So this is going to be our first set of data.
So what's important there is because of the buffer. So you did, 30 requests, but it buffered, Firehose buffered it.
It buffered it. It probably ran up against a time window because we definitely didn't wait 60 seconds. It didn't buffer it based on the size of the data, because I think we got what, like 100 kilobytes or something.
Right.
It was tiny. Firehose breaks it up into time windows of 60 seconds each, counting off 60 seconds. Did I get any data? Did I get any data? If it got data in that 60-second window, it writes it out. It batches it and writes it. So this, we can take a look at this one object. We're going to take a look in JSON format, so it's a little bit clean. And we are going to show the file preview. So you can see, randomly generated name, James Rich, ingestion date time, these should all be about the same. I click pretty fast. And then random text. So a couple paragraphs of random text here. And it just keeps going. And then, let's see, we can back out here, and if we refresh, there should be another one that popped up. Or not.
Well, wouldn't it only take another one to do it across the 60 seconds?
Yeah, it crosses now.
Okay.
The buffer, like when you hit the request, that was under 60 seconds, so it will cut one file. So if you kept clicking refresh past 60 seconds, it will cut one file. Which shows the benefit of files is when it's not, you can
Minimize
request more than a
each
byte.
one of these would have been its own right.
Every put request on an S3 bucket is a cost, and your cost goes up.
Is that buffer size one of the parameters you set when you created the firehose?
Yep.
You get 300, right?
Yep.
One of the challenges we ran into was, what was the challenge? It was you weren't filling them. We wanted to do like 100 meg buffers, but you weren't filling up the buffer faster than the max time threshold. So, what's the max time threshold?
Right now for this.
That you can set as a virus.
Let's check that.
15 minutes or something?
It's 15 minutes or something like that.
So like
It's calculated to
after 15
seconds.
minutes, it would still cut a file regardless of the buffer. So, so then we started, that was like when at the beginning when we started ingesting large amounts of data. So obviously if you're not doing enough data, you're still going to cut the file at whichever max you hit first, size of time.
And you want to think about that that size buffer.
Right, that was good for a course factor, right?
Yeah. Yep.
You imagine it would be very slow if there was a lot of opportunity to read them. Every time you read a file, that takes milliseconds.
It's a call, yeah. It's an individual call. So you do want to think about that that size buffer as well, because you're going to be reading, processing that data later. Yeah.
That data is at risk while it's in that state.
Yep.
Is there a reason for concern about that?
In S3 or?
At rest? So it was a part of
this stage in the firehose, but before the write, before it's inclusive of the size of the time threshold.
I don't believe it's considered at rest in the firehose itself. I think we had,
at risk.
at risk. Oh, I'm so sorry. Yeah.
Losing it? Yes.
I don't think I've lost any data from the firehose. It's really reliable.
I don't know if they're
SLA.
I guess we're looking at what their SLA is. Like if firehose scales and then it has an issue, so Amazon has a problem. I don't know if it has a persistent. We actually did look at firehose because one thing with this data, the Slack data, we put encryption in place. So in case you had sensitive data and you wanted to encrypt it, technically, even with Kinesis, when you had it in memory, there's still a persistent way that it stores it. And when you can dive too deep into it, but you can encrypt it through, or you can encrypt just using Kinesis itself. But what we got into was talking about how if you take that, like when Kinesis fills up, is it persisting in kind of like a Kafka, where you have an offline storage where you could bring it back up and you have an outage and stuff like that. We didn't go too deep into that, but we were looking at the same topic was because of more of the security standpoint, like are they persistent on their servers? And if they're persistent on their servers, then technically it's encrypted, but is it in memory or is it in flight? So it's a good question. I don't think we go too
So we're encrypting on the S3 side right now. I set up for this demo, we set up Amazon encrypted, Amazon managed keys. Yep. So there's an option for AWS managed keys or KMS, which would be you manage your own keys. I just set up Amazon management for this one, yeah. All right. So yeah, that demo worked, thankfully. So we don't really need for questions.
Did you try doing it with
I didn't. It's an option for sure. And in that case, the serverless framework, a lot of that configuration you're doing is done from the config file, which is then kind of built through CloudFormation. I did more this way for like demo purposes, so we could see each option as we went along.
But at the end of the day, you're at the same spot.
Yeah, so same thing, you just don't go to the console, right to the YAML file.
Yeah, it's a good way of basically declaring everything in YAML. And behind the scenes, the serverless framework is self-sufficient there. Because everything you saw there is available on Amazon REST APIs as well. The serverless framework with CloudFormation orchestrates all that. Just declaring a YAML file saying, S3 bucket called this, and when I am all of this, and it wires it all up for you. Which is really what we've done different than a different example of serverless framework for a different serverless use case.
You're right.
You mean like after the fact?
Yeah, like from right now, like write this up and then just tear it all down, rebuild it all.
That's where the serverless framework helps. When you have that YAML, you literally do not manually do anything. You literally tear it down and you rebuild it.
You make that YAML, so you
Reverse it?
gotta put it all together.
Yeah. I don't know if it's experiment with that. There is a service framework too. I love that. That's actually interesting. It's reverse generating.
Hey, Greg.
What's up? Oh, sorry.
If you don't mind. I have a couple of questions because this is like an interesting use case, probably similar to what we do and a lot of those use cases. Do you have any issue when you're dealing with Kinesis Firehose or with, well, two questions. So with Kinesis Firehose, when you're cutting files, so to speak, on a time boundary more commonly, right, like every 60 seconds.
Yep.
Do you find that there's ever, have you ever experienced any, like, or done any testing around the reliability of it? Like, the end of the last file is exactly the beginning of the next file, and there's no time gap whatsoever, and there's no duplication across that boundary. All of the little problems you might expect if you're buffering something.
We were running into an issue where we would see partial object state, I believe, at one point.
Like hit the side boundary or something?
For the size boundary, it would find the last complete record that you sent Kinesis, and it would wait till it got to the end of that record, and then it would write it.
Also, it might overflow the size boundary by one record, in other words, or four.
It would, yeah, just about, yeah. So, yeah, it would just keep going up.
What's an interesting use case though of that is when that overflows in massive.
Like, I wonder how that
Each record's a gig.
Yeah, like every record's a gig, and then you're like, oh my, look at 1 KB, you have to go to a gig. That would be a great thing.
Yeah, it'd be fun.
There was a limit on the, there's a limit on the Firehose writes, so you wouldn't be able to get an overflow of about a gig. I think it's the max. Yeah, the max for each record is, was it 50 meg or something? Or, yeah, something. It's pretty small. Yeah.
And then the other question I had in this universe was, so you've written the data mangling, the taking the raw data, processing it using a Lambda. That makes sense to state of historical stuff?
So, it's not something where you'd be able to, I mean, kind of technically be able to almost replay um, individual Kinesis writes. So, individual objects that Kinesis writes to S3, so that those 5 megabyte chunks, you could reprocess each of those. And I would think the best thing to do would be to trigger a lambda off of each of those objects, so you can do it in a kind of horizontally scalable way, and then send those reprocessed data chunks to another fire hose, which would write to another S3 bucket, which then handles whatever additional use cases you come across.
Why would you need to reintroduce Firehouse? Like, is there some way that you can just like, I guess what I was hoping for was something that would just be like, oh, find me all the files. I mean, maybe it's just a script. I don't know.
Yeah, I think what you're referring to is what we had to do for when the raw data is processed, when the raw data is taken in and stored, right? It's just raw, sitting there. So
Yeah.
Twitter, Slack data, RSS data, stored in an S3 bucket raw. We had to reprocess the data, which was visible. And that's where we talking about CloudWatch, where we also separated our lambdas a lot, because lambdas technically are functions and it's a purpose. It's okay to have 100 functions. And, that's what serverless framework. Period. But we walk share all the thing out with all the jobs. But we did it so you run that first, URL scraper and you iterate through the data, right? In our use case, you could iterate through the size of this data to just find URLs pretty quick. Awesome. And then you basically, when you get that URL, you need to dispatch that. You dispatch that to lambdas. And what that happens is you then scale from there. So you can kick off the trigger of the lambda that does the initial processing. Obviously, if you're talking like terabytes of data, sequentially is not the right thing. You probably tackle it with driving it through different ways of grabbing that data. But in the end, it was to reprocess it. You could run that initial scan, grab it, and then dispatch it to other lambdas, which then can scale out horizontal. So if this one's scraping, that one's scraping, you could scrape. Well, they all can start scraping and doing it up independently and processing after that.
So when you were reprocessing the data, you actually re-scraped it as well?
So if there's rules on the re-scraping of the Slack data, like, oh, we want to go 3 levels.
I see.
That would be paragraph tags versus header tags. So we felt like in the machine learning world, we're thinking, technically a header, an H1, means something different to a website than a paragraph. A header is more like, right? So it's like, well, if you put rules and weights based on a header, and then weight that higher than a paragraph based on that, we can reprocess it. Now, after the fact, we do the same thing. You have a raw data, right, after the scraping. The same thing can be played. What we did there, we took that out, and then we generated different rules from that. So get rid of all special characters. So that would screw up your machine learning algorithm. So in that way, you can take that and dispatch that out and different processing jobs. And then we have another one where we extract the data in a clean format. So when you have word vector, you don't want to read, JSON. You want everything literally raw text form. So I think by the way that you could break apart functions to the mining operations, you can have that rescan triggered that can then do dispatch. And you could do many rescans or split it out by timestamp you had it or by day. And each one takes a day, right? And you split it out. And the cool thing about Lambda is you can just farm it out and scale as big as you want. But you kick off the processing with CloudWatch.
If you don't have data in this bucket and it's raw, you don't use lambda that says, go get this raw data, process and distribute it like your HTTP call.
Yeah, that was more what I had in mind, but maybe
If you're saying, maybe I was misunderstanding the question. If you're trying to just trigger the reprocess.
Yes, that's what
Which is an initiative done via CloudWatch when it writes to that C bucket, but you don't have that CloudWatch event anymore.
that's what I was
Yeah.
No, so CloudWatch allows you to trigger on a scheduled basis if you want to. You can schedule
Yep.
Level.
So it's running as the data comes in for us.
And so the payload from that
It's a great structure.
is the S3 object.
The payload for what? I'm sorry.
The payload from the S3 write event
Yep.
has the S3 object in it, right? That makes the
Actually,
processing
no.
object.
It gives you the
Or it
identifier.
just gives you the key.
It gives you
and
the
then
key
goes
for that, and then you
into
have to run out and grab the object itself.
So when you do the data transformation, do you have two buckets at that point?
For data transformation.
One for raw, one for post.
Okay.
Yep.
And the point is to always keep the raw.
Yeah.
You can consider it empty.
Do the kind of thing I was saying.
Reprocess it.
Yeah.
Yeah, for that point, again, like you checking, you reprocess that data, it's still in the bank. It may happen today, it may happen every week, or it may happen once a year or on a random basis, but it's still in the bank. You start to check the random for that data. Either an IO or.
Yeah, man, I mean, you think about it, if you have, like, this was a simple example, but if you wanted to split your data, I mean, it might make sense to split it by date or by some category. And if you do it that way, you can still kind of break apart the way you're going at your data to reprocess. And I say farm that out, and you can have a generic lambda doing the job, if you're telling, use these X records or this folder, 2018, or whatever, so you can trigger it off the HTTP event, you can trigger it off of continuous weekly job, if that's the pattern. What here is there's a real-time event-based as you write, because you can use triggers on S3, you can use, API gateway triggers to start, so you can just kind of chain real-time triggers, or you could command as well.
It does. It turns out that, like, if you're thinking of analytics as the use case, the problem is a little more complicated, right? So maybe you actually need this processing script to only work on these events, and actually that changed over time, and then it's like, ooh, I need to do a it all worked as it was streaming in, but now when I need to reprocess, I need to use different rules for different time. It could be like pretty complicated.
Yeah. Now, I just have this scenario. I think it's scenario saying like, I just need to like reprocess all the events for November, all the events 2018, something like that. And it's usually the person who's deciding. I'm deciding to do that. So in those cases, I'm going to prioritize the right script and do it.
Yeah.
It's like one-off thing. You know? I don't know if there's a practice behind that, but I've always said. In every case, pipeline, someone always brings this scenario up. I'm like, well, if that scenario happens, we'll break that fix it.
Well, I think the script, I think date is probably the most important thing, because that's not going to change. When the date is you structure the data coming in, you're storing it at some, time at a month level or a week level. No matter what rule you say or how you want to reprocess the data, you can go get that range of data by the date, regardless of what business it is. Now, you might write another lambda that's triggered off something in the process. But that lambda could be that script. It could be, all right, I'm going to take this data, I'm going to rip apart some analytics tag and do something, but in the end, what's not changing ever is the data which the analytics can in. So you could base it off of the, break it apart by the data and then write some analytics script.
Yeah, I guess the thing that in S3 is that you have that historical data stored, whereas if you're using some other sort of hub sub, that's not.
Right.
It's just
Yeah,
in the
way
system
better
is
for
advanced thing, but who's those events and move over to templates.
So I think our presenter's point is this architecture is pretty flexible, and there's a lot of extensibility points. And you can find ways to meet your needs. Totally. Thanks for the visit.
So now we'll get into lessons learned. So you want to keep an eye out for choke points. Any place I mentioned where the max memory usage is set too low, or the max time allocation is set too low, you can see errors in either of those situations, and it might actually cause issues down the road, farther down in the pipeline. You want to minimize the memory usage in horizontal scanning for the same reason. If you find yourself, like I mentioned before, messing with those two attributes too much, the max time and max memory, you want to rethink the way you're doing things. You might not want to do it in a lambda, or you might want to do it in a different way. So Kinesis writes to S3 exactly what you give it. So when you're passing individual objects into Kinesis, if you aren't appending a separator for each of those objects, you're just getting object, 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 and that can mess up some JSON parsing. So you either need to find a way to separate those individual objects, or you need to add a separator at the time of write. And then CloudWatch logs are your friend. Almost any issues that you're going to run across will show up in CloudWatch. If you find that you're seeing a lot of, you just want to keep an eye on your system as it runs. Just watch logs regularly as you build it, and a lot of those issues will present themselves for your fix. Get good at writing useful log statements is also another kind of thing you want to make sure. You won't know what the problem is. I don't know where my data is. What am I going to do about it? All right. Any questions? Any more questions?
Wondering, would it be interesting to go to that memory issue that you ran into?
The one where I was trying to do too much in Lambda and didn't like it? Yeah. So what I ended up doing is I was reading from S3 in my Lambda. This is an issue we ran across. We were coming up against a memory error. I was trying to read S3 from a Lambda. So I was retrieving a list of objects that were stored in S3, and then I was going out to S3 and reading each of those individual objects. And because there were so many of those objects at a certain point, at the start, it was fine because I didn't have a lot of data, didn't have a lot of objects, everything was fine and dandy. Maybe like a month down the road when we scaled from, we're taking kilobytes of data to now we're at like hundreds of megs, that's when the issue showed up. So what I ended up doing was kind of parsing that out. So now I still pull in the list from one Lambda, but each of those objects is now processed in a separate Lambda. So you pull in a list of objects that exist and pass them individually to another named Lambda, which scales horizontally so that you don't have to worry about giving one Lambda, all this memory to do all this processing, which is silly.
Is there like a maximum S3 file size or a buffer that you would recommend doing a processing step with a Lambda? I mean, I guess presumably you can have bigger or smaller. Like were you finding 100 megabyte chunks is okay, or is that gigabyte chunks?
So for the writes to S3 from Firehose, that chunk.
I'm sorry, I mean the processing of your raw data from within another, say another Lambda will trigger to turn that to processing.
So in the current pipeline, that's done triggered on write. If we were to go back and process each of those individual objects, what you'd want to do is pass each individual object to its own Lambda, right? Maybe I'm misunderstanding.
Right.
A number?
I'm not asking about the file size limit on S3. Sorry.
Are you thinking about how much one Lambda can process? If you want to reprocess terabyte of data later, and then you start throwing 100 megs of data at a Lambda at one shot, then it blows up, right?
Yeah. So
if you could split it out more efficiently and make Lambdas process the little amounts but use more Lambdas.
Yep.
Well,
so that's
it becomes no longer becoming an architectural issue because if you thought it was okay to store your file size at
the Firehose has that buffer limit. So the Firehose is limiting that on that end. So if you have 5 meg chunks, I think there's a limit also on the size of the chunks that Firehose is allowed to write to. And that's nowhere near what a normal Lambda will cause a normal Lambda to crash.
Okay.
So you shouldn't really run across that issue.
Okay.
Any other questions? All right, that's all I got. Here's some social media stuff for Ken's on. All right.